All right, we'll try again. An acute angle is any angle that's less than 90 degrees. An obtuse angle is anything greater than 90 degrees. Of course, you should know what a right angle is. It is exactly 90 degrees, but that's not one of them because you're supposed to have already known that one. The next one would be a straight angle. Okay, now a straight angle and a line are going to look similar. The difference between a straight angle and a line is the fact that the straight angle will have 3 points on it. A line doesn't have to have 3 points. It can only have 2. So when you're trying to identify the difference between what a line looks like and a straight angle, the difference is a straight angle has 3 points. Okay, a line only has to have 2. So if you only see 2 points there, you can't name it a straight angle. It has to be a line. All right, number 19. Number 19 is called the incenter. Okay, now the incenter is created by angle bisectors. Okay. So understanding what an angle bisector is, you did that with your last cards, is that these are all points that deal with segments of a triangle. So all of this is triangle work. Incenter, orthocenter, circumcenter, and centroid. These are all involving a triangle. An incenter is where all the perpendicular, or where all the angle bisectors meet. So if I bisect each angle, okay, and how do I know they're bisected? You would be by the congruency marks. So I put a congruency mark there and a congruency mark here. Okay. Notice 1 tells me those 2 are equal. 2 tells me those 2 are equal. And once you have 2, the third one would have to meet there. Okay. But the incenter is where all of the angle bisectors meet. That is called the incenter. 20. 20 is called the orthocenter. Okay. The orthocenter is where all your altitudes meet. Now, that is one I don't think we did in the beginning. I'm not sure. Did I? Did I do an altitude? Nope. So this would be one of the cards you're going to have to add. Okay, so we'll put 20 and 21 next to each other. 21 is an altitude. Okay, an altitude is a right angle mark. Okay. It is also known as a height. So that means anything that has a right angle mark to it, this would be the altitude. Okay? The line that makes the perpendicular angle. The line that makes a right angle is called the altitude. The one line. Not both lines. One line's going to be there. The line that makes the right angle is called the altitude. Altitudes can change shape. Like you can have an altitude drawn sideways. This is still called an altitude. Just because the picture's sideways doesn't mean it's not an altitude. Okay? The altitude is the single line that is drawn that is perpendicular, not the line that was already there. Okay? In a triangle, when all the altitudes meet, okay. Now the definition for the altitude is going to be in your book. It's a line that starts at the vertex and goes to a base. So in other words, an altitude only exists in shapes. Okay, it's never all by itself. So for example, here's my shape. This would be my altitude. Starts here, ends here. Okay? Altitude always starts at a vertex, which means you have to have some sort of shape. Okay? Can you have an altitude in a circle? No, why? There's no sides in a circle. Good job. Excellent. Cannot have an altitude in a circle. What do we call that line segment in a circle? It's not called an altitude. It's called the radius. Yes, it's called a radius. From the middle to the circle is called the radius, and all the way through would be called the diameter. Good job. All right, so an orthocenter is where all of these meet. Now, this changes. It can meet in the triangle, it can meet outside of the triangle, and it can meet on the triangle. Okay, it depends on what it is. In an acute triangle, the orthocenter will be in it. In an obtuse triangle, it will be out of it. And in a right triangle, it will be on it. So in other words, the orthocenter will be outside of this obtuse triangle. Well, why? Because the altitude for this vertex will be outside. Just like the altitude for this vertex would go this way. No. They extend out further. So you're looking at something that looks like this. It would meet somewhere down here. So understanding that it meets in different locations, but it's where all of your altitudes meet. So in an acute triangle, it's the easiest to do. It would be here. Now it's similar to an in-center, but it's not the same. Okay, these angles aren't bisected. These are. These are just altitudes. Okay. All right. Next one, circumcenter. Circumcenter is where all of your perpendicular bisectors meet. Okay. And perpendicular bisector is a vocab flashcard that you have later on, which is fine. But perpendicular bisectors are both perpendicular, which means it does this, and it cuts the side into two pieces. So in other words, if I said draw a bisector, you could do this. That's a bisector. If I said draw something that's perpendicular, you could do this, and that's perpendicular. When you have both marks on there, it is both. It's a perpendicular bisector. It doesn't have to look perpendicular as long as the mark is there. So you have to be very careful because sometimes in geometry the pictures aren't what they don't look like they're supposed to, and they have congruency marks or right angle marks there. And you're like, well, that doesn't look like a right angle. Nobody cares what it looks like. Remember, in geometry, if I said, why is that perpendicular? You can't say, because it looks like it. Okay? Because it looks like it is a recipe for disaster. It's not because it looks like it. There has to be something there, some sort of information that tells you why it is. That's what makes geometry a little bit more difficult, because you have to memorize pictures. Okay? So the circumcenter and the orthocenter are similar. The difference is the perpendicular bisectors don't have to start at a vertex. So like this is a perpendicular bisector here, but notice it was off to the side. It wasn't from the angle. And then the last side right here would be a perpendicular bisector. But notice it doesn't go to the vertex. This would be called the circumcenter. Now, circumcenter and altitude have something, or circumcenter and orthocenter have something in common. They can meet in a triangle, on a triangle, or outside of a triangle. Outside if it's obtuse, inside if it's acute, and on, in other words, the orthocenter would be where the altitudes meet, which is right here. Okay? The orthocenter of a right triangle is always on the vertex here. And the orthocenter, or the circumcenter in a right triangle, will always be on the hypotenuse. It's always here. So in a right triangle, it's in a very specific location every time. In the orthocenter, it's always here. And a circumcenter, it's always in the midpoint of the hypotenuse, always. Now, in your acute and obtuse, that's where it ends up being in different places. But the two most commonly used are the ones with the right triangle. Next, Centroid. A centroid is where all the medians meet. Median is the next one that we have to add to our vocab. So the 21, 22, you'll have 32 so far. So I'll put this down as 32 as what a median is. A median is a segment that starts at a vertex and bisects the side opposite it. Okay? So a median goes like this. And that's all the congruency marks you'll see it. A median is named a median because it starts at a vertex and it bisects the side across from it. Now these are all names for segments that are inside of a picture. So most of them are triangular work. Okay? And I will tell you, most of the year you'll spend dealing with triangles and the rules that go with triangles. And then about a fourth of the year, so if you were to cut it into fourths, this would be half. Another 1/4 would be four-sided figures, quadrilaterals, and then another fourth would be circles. So you deal with those three main shapes. And the irony of this is it's the same thing that you do for the SAT. It deals with three basic shapes. Pretty much every picture they give you is either going to be triangular, quadrilateral, or circles. Okay, so the centroid is where all of your medians meet. The centroid always meets in a triangle, just like the angle bisectors always meet in a triangle. The in-center is always in the triangle, and the centroid is always in a triangle. So no matter whether it's acute, obtuse, or right, the centroid is always in. So there would be a bisector, there would be a bisector, and here would be a bisector. Okay, this would be called a centroid. Now, mathematically, there's an equation that goes like that with this. This is 1/3, this is 2/3, meaning every median is the same distance, like this. This part, like if this was 4, this piece would be 8, and the entire median would be 12. It goes 1/3, 2/3, and you add those together. Obviously, you get 3/3. So if this was 2, this would be 4. This whole thing would be 6. If this whole thing was 18, then one piece of it would be 6 because you divided by 3. Good job. And then this would be 12. So it's understanding the relationship in a centroid. Okay. You have to know that a centroid is where all the medians meet. But really briefly, the math that goes with it is something like that. The math is not difficult. It's just understanding the concept. Then you learn different rules, like when you have a in-center, it's the same perpendicular distance to all the sides. When you have a median, it's the same perpendicular distance to all the angles, or it's the same distance to all the angles. So there's lots of rules you learn that goes with the pictures. This is just very basic. Like, these are just basic definitions. Okay. The application of these definitions is a little bit more intense. And again, it's mostly memorization. Parallel. Two lines that have the same slope. Please do not use your 3rd grade definition, they don't touch. Okay? Everybody knows they don't touch. That's not what parallel means. Because you're going to learn about another set of lines called skew. This would be number 33. Skew. Those are two lines that don't touch but aren't on the same plane. So let me give you an example. Skew happens in 3D. Parallel happens in 2-dimensional. So I'll give you an example of something that's skew. And I'll use the room as an example. Okay, so this is a 3-dimensional object. This is what we would call a rectangular prism. This room is a rectangular prism. And if you look at the baseboard over there on the bottom, that means between the floor and the wall, it's called the baseboard. You'll notice that it is parallel with the ceiling and the wall. They both go in the same direction, they have the same slope, and they don't touch. Skew would be as if you turn the corner and I go over here. You can see where the wall meets the ceiling on this side of the room and the baseboard is on that side of the room. They go like this. That's what skew is. Notice, they're never going to be touching, and they're not on the same plane. Like that's on this wall, that's on that wall. And they don't go in the same direction. Okay, so when you're dealing with three-dimensional, it's called skew. They don't touch, and they're not on the same plane. And parallel means they don't touch, but they have the same slope. The key here is that they have the same slope. And this was the big concept you were supposed to get in algebra. Everything with the same slope is parallel, which would be one of the reasons why you always found slope. The second reason is to figure out if it was perpendicular, because perpendicular has opposite reciprocal slopes. Okay, so if I gave you the slope of 1/2 and 1/2, you could tell me those were parallel. If I give you the slope of 1/2 and 2, you can tell me that they're not parallel. And if I give you the slope of 1/2 and -2, now these are perpendicular. Okay. That's what you're supposed to be able to tell with slope. This is from Algebra 1. Okay, the next one's perpendicular bisector. I already showed you what that looks like. It's perpendicular and it bisects. Isometry. Isometry is where something is identical on both sides. Okay? Now, the definition in the book is much better, but I'm giving you just a general concept. Isometry is just understanding that it's like the butterfly. Most of you've done isometric pictures all the way through flipping elementary school. You know, where you would take a piece of paper and you'd use that chalk and you'd like do one side and then you'd fold the paper over and rub it and it would transfer over to the other side. Many of you used to do that with tin foil. You did it with a bunch of different things. Right. You'd sketch one side, you'd flip it over, you'd have the paper that was real thin, you could sketch it on the other side. I mean, there's lots of different ways of doing it, but that's what isometry is. Now, in geometry, the only thing is everything's a shape. Like, it's not a butterfly. Okay? They're like triangles and rectangles. And so isometry is understanding that when you have a line, everything on each side is equal. Okay? So you'll have isometric pictures. What in algebra was isometric? Where did you have isometry in algebra? You spent not half the year, about a quarter of the year working with it. Half the year we did lines. What's the other half, or the other quarter of it we did? Anybody? Well, there were quadratic formulas, but that's not the thing that's isometric. What is it? The parabola, right? The parabola is isometric. So, when you had your axis of symmetry, that's where isometric comes from. The distance from that is the same. Okay, and then you have vertex. Now, this is a word that has several definitions. Okay, you can put all the definitions on one. You have to know the difference. Like, for example, there's a vertex in a parabola, but a parabola is not a geometric shape. There's a vertex in angles. There's a vertex in figures. Now, hopefully you understand shapes are two-dimensional. Figures are three-dimensional. So when I look around here and I say there's a vertex, that's the corner of the desk. Now, technically, would this be a vertex? No. Why? Because it's not a corner. It's rounded, right? It can't be a corner if it's rounded. Now, it's a corner. I put this over it, it's rounded. So this is now a corner. Your desks don't have corners, so they don't have vertices. A vertex and vertices. Vertices is just more than one vertex. Okay, so this is one that has several different pictures. Why? Because everything has something called a corner that's called a vertex. But not all vertexes are called the same thing. Does everybody understand? Like, I look outside, there's a bunch of cars in the parking lot, but every car has a very specific name. That's the same thing that happens in geometry. Based on the picture you have, your vertex could be a vertex angle. A vertex angle only happens in an isosceles triangle. So you will have more specificity. In a parabola, it's called a minimum or maximum. It's still called a vertex, but it's called a minimum or maximum, and that tells you it's in a parabola. So all of these have different names. Remember, if you're not going to write or do anything, I don't have a problem with you not doing something. I just don't want you to do it right in front of me. So, next one is coplanar. That means everything is on the same plane. Okay? So that means if I have a point way up there, it's not on the same plane. So that point is non-coplanar, but all the rest of them are. So if I give you a list of points and I don't mention this one, then the points that are on here are coplanar. The moment I mention this point, then it's non-coplanar. So understanding what coplanar and non-coplanar is. Congruent. These last two should be something that, or these next two should be something you're familiar with. What does congruent? Same size and shape. Right. Same size, same shape. What is similar?
Same shape, different size.
Right. Same shape, different size. Two big concepts. Now, I will tell you that congruency has this mark. Similar has this mark. So you have to know that that means congruent. This means similar. And this means equal to. You can only use the equal sign when you're dealing with numbers. You use the congruent and similar sign when you're dealing with shapes. So that means when you're talking geometry, you got to use congruent. Like this side is congruent to this side. You can't say this side is equal to this side. You can say 5 is equal to 5. The measure of that side, 5, is equal to 5. But when you're talking geometry, you have to use congruent. That's what signifies the difference between geometry and algebra. In algebra, we use nothing but equal signs because we're dealing with numbers or letters that are holding the place of a number. In geometry, you're dealing with other letters. Notice all of these letters are capital, whereas here, all the letters were lowercase. All your variables were lowercase. So it's understanding that you use congruency when you're talking about shapes or geometry, like angles, line segments. If I'm talking about the numbers that goes with it, like the measure of an angle, then I use the equal sign because the measure is a number. Numbers are equal. Shapes are congruent or similar, right? And transversal. That's the last one. The transversal is the line that goes through the parallel lines. So if I have a set of parallel lines, this would be called a transversal. This would be called a transversal. But if I do this, which tells me these two are parallel, now this is the transversal and this is a transversal. So you can have more than one transversal, and parallel lines can also be their transversals. It just depends on which pair of lines you're talking about. If I said name a transversal to the parallel lines A and B, well then you would name this right here, or this. If I said name the transversal to the parallel lines C and D, oops, it's my dyslexia, C and D, it would be either A or B. So understanding what a transversal is a line that cuts through a set of parallel lines. Alrighty? And that is it. I expect to see your projects on, when do they due? You tell me. Did you look on Portal? Which would be? No, it'd be next Thursday. Right, the last time I would actually see you in class. Well, unless you are unfortunate enough that your parents make you come to my class when we don't have an exam. All right.